Hello! Today we're covering basic Solana dev terms. Whether you're new to Solana or just want to understand the lingo, this video will help you quickly get up to speed and join conversations with confidence. Let's dive in. Solana is a high-performance blockchain designed to support decentralized apps and crypto projects. It was launched in March 2020 by Anatoly Yakovenko and his team. Solana stands out for its scalability, high throughput, and low cost, achieved through innovations like proof of history and parallel transaction processing. Solana can handle more than 65,000 transactions per second. Just think about it. Transaction fees are incredibly low, averaging at $0.00025 per transaction. Solana has millions of active users and a thriving ecosystem of projects, including DeFi platforms, NFT marketplaces, and gaming apps. Its market capitalization places it among the top cryptocurrencies globally. The Solana community emphasizes innovation, developer support, and accessibility with initiatives like Solana hackathons and user-friendly tools like Anchor. Solana was founded by Anatoly Yakovenko. He introduced key innovations like proof of history to solve blockchain scalability issues. Solana Labs, the core development team responsible for maintaining and upgrading the Solana protocol. Validator. Validators are nodes in the Solana network that process transactions and add new blocks to the ledger. They earn rewards from transaction fees and staking. Proof of history is Solana's unique way of keeping time in the blockchain. It's like a cryptographic clock that timestamps transactions before they're added to the ledger, making Solana super fast compared to blockchains that rely on traditional consensus. Proof of history is a cryptographic technique that timestamps events on the blockchain. Proof of history uses a cryptographic function to generate a sequential verifiable chain of hashes. Each hash is dependent on the previous one and contains a timestamp, creating a reliable history of events. Validators can organize transactions based on this pre-established timeline without waiting for network-wide consensus at each step. Unlike proof of work or proof of stake, where consensus is tied to mining or staking, proof of history decouples consensus from transaction ordering. Why is it faster? Validators can process transactions in parallel instead of serially agreeing on a block. Proof of history minimizes communication overhead, allowing Solana to reach its high TPS while maintaining security. An epoch is a unit of time in Solana, roughly 2 days, used for staking and reward calculations. Sol is Solana's native cryptocurrency. It's used to pay for transaction fees and staking. A Lamport is the smallest unit of Sol. 1 Sol equals 1 billion Lamports. They're named after Leslie Lamport, a famous computer scientist. Fees on Solana are small payments to process transactions. There are 3 main types: transaction fees, paid to validators for processing transactions. Transactions fees are paid for executing smart contracts, but what Solana does differently is fees on Solana are local to the app you're using. This means congestion in one app doesn't raise fees for others. Prioritization fees, an optional fee to boost transaction processing order. rent fees charged to store data in accounts. The best part, the rent fees are refundable. Yay! If you close the account, you get the storage fee back. Thanks to this structure, Solana's median transaction fee remains around $0.003 even during peak usage. Accounts in Solana are where data is stored. Unlike traditional blockchains where smart contracts store data, Solana separates programs, logic, and accounts data. Every interaction modifies or reads from these accounts. On Solana, storing data in accounts isn't free. Rent is the cost of maintaining space on the blockchain. However, if you pay enough upfront, your account can stay active forever. This is called rent exemption. Since the blockchain's storage is finite, rent ensures resources are used efficiently. Rent is calculated based on account size. Larger accounts incur higher costs. Rent rate, set by the network, it's typically a fraction of SOL per byte per epoch. Rent exemption. If an account's balance exceeds a threshold, it becomes rent exempt. The exemption threshold is calculated as follows. This balance must remain in the account to keep it rent exempt. When an account is deleted or closed, any remaining rent balance is returned to the user. This mechanism encourages users to clean up unused accounts, freeing storage and maintaining network efficiency. Rent and rent funds help Solana maintain a lean blockchain, ensuring that unused accounts don't blow the network. In Solana, a program is the same as a smart contract. It's code deployed on chain to define what happens during transactions or interactions. Programs are written in Rustlang or with Anchor. It is a framework that simplifies writing Solana programs. It uses macros and conventions to reduce boilerplate code, while Solana's native development is done in Rust. Anchor makes Rust more beginner-friendly by handling common tasks like account validation. Native programs. These are pre-deployed programs built into Solana, such as system program that handles account creation and transfers, token program which manages fungible and non-fungible tokens, stake program which manages staking for validators and delegators, and more. AccountInfo. A structure in Solana programs that contains metadata about an account, like its address, owner, program, and whether it's writable. Developers use it to manage accounts interactions. ATA, Associated Token Account. It is a special account that holds tokens for a user. It's automatically derived from the user's wallet address and token mint address, so each user only has one ATA per token. Instructions or functions or extrinsics. Instructions are commands sent to a Solana program telling it what action to perform. For example, transfer tokens or stake SOL. Multiple instructions can be bundled into a single transaction. Transaction is a set of instructions combined into one atomic action. It's signed by the user and sent to the Solana network for execution. Escrow. It is a temporary account used to hold funds or tokens until specific conditions are met. It's commonly used in token swaps or other conditional exchanges. It is similar to how you buy from Amazon. Your funds are being held on this escrow account until the seller delivers you the product, and then he gets funds from this account. Sysvar. These are accounts that are read-only and they provide system-level information like timestamps, recent block hashes, and rent parameters. ED25519. This is the cryptographic signature algorithm used by Solana for securing wallets and verifying transactions. It ensures that only the owner of a private key can sign transactions. A PDA is a special account address derived from a program's logic. PDAs have no private key and are controlled by the program itself, making them perfect for managing program-owned accounts. A program-derived address is a unique program-controlled account on Solana. A PDA is derived from a program ID, the smart contract's address, a set of seeds, deterministic inputs such as user addresses or parameters, bump, a small number from 0 to 255 added to the inputs if the generated address conflicts with the existing ones. Role of the bump is crucial. It ensures that the derived address doesn't collide with an existing private key address. If a conflict occurs, the program adjusts the bump value until a valid PDA is generated, so going from 255 minus 1 and so on. This guarantees that the PDA is unique and securely controlled by the program. The bump is stored or saved, so it can be reused for deterministic access to the PDA later. PDAs are often used to store program state or user data, manage escrow accounts in token swaps, automate workflows such as staking rewards or governance voting. Key benefit: security. No private keys are needed, so PDAs are tamper-proof. Programs can recreate the same PDA consistently using the same seeds and bump. Because PDAs are deterministic and controlled by programs, they provide secure, trustless account management for complex interactions. CPI is when one program calls another program on the Solana blockchain. For example, a custom staking program might call the token program to transfer tokens. Token mint: a program or account that defines a specific type of token, including its total supply and decimals. That's it for today. I hope this helps you get more comfortable with the vocabulary and dive deeper into building on Solana. Thank you for watching. Bye!